Okay, the recording has started. Yes. Okay, let's join. Let's see if it actually works. Microphone.
Rusty?
Broken.
I kicked the battery into the e-waste bin after this.
That's going on the floor. That's why we can't have nice things.
I'm gonna message next week. Oh yeah, next week.
Bro, everything's been left on, so it's just like look at this poor mouse. It was on this whole time, so now it's dead too.
Thanks for finding out the grades on the exam 3 day. Hillary.
I'm gonna steal it.
Left it up.
At this point, yeah, like no one, not other than anyone can come back for it.
It's not good conscious thing. I'm not good to see.
Oh, you can't even see it. Focus. Ugh. It's all horrible. Okay, start with it. Sometime today, the solutions to exam 2 and 3 will be posted. Any of y'all want to see any specific question other than exam 2 and 3? No, I'm waiting for it to be a little more.
You don't want to be the first.
No, it's so the one I want probably is a little bit frozen, right? A little bit like thawed out. So I want it to be nice and crisp.
When is he gonna grade that third test?
Bro, that man better be grading right now because.
I'm like, I need to know what my grade is.
Bruh.
This is optional.
You can help
grade
him
is.
with grades, right?
Huh?
I want to grade
You can
himself.
help him with grades.
He doesn't want
Because I mean, this has been Friday, Saturday, Sunday, Monday, Tuesday.
Oh, also, I think he did great. I think he took a little bit today because one of the softwares he uses, the expiration ended.
Wow.
So we take it on
Whatever.
Yeah, but it's not optional if you don't get the grade in time.
When's the project where he's going to post
Look, I did my part on that.
Well, he tell me, I told him, we have 2 exams. He tell me, good for you.
Like he gave me a week to look at all 40-something codes. And he's like, have it to me by Friday in the Excel sheet saying which code works, do the graphs work. I had it to him on Friday.
Oh my God.
That was how long ago? When was the project due?
A while ago.
Like
spring
March
So he had since March.
Spring break.
So he had since March.
He breaking. That was good for you.
He,
That's what he keeps saying. I need a grade. And I'll make this easy.
he just needs to look at them and be like, okay, here, you get this point, you get that. Here, you get 100, you get a 75, you get a 50, you get a 25, you get a 0.
I reserve 100. It's too small, 6.
Excuse me. He said exam 2 and 3, we can work the optional exam for first semester, the first question. Another load, yes, this up, yeah. That's what we can do that. I don't
Tell
know.
us what the extra credit on last year's.
Yes, what's that? So EMAG.
The first question?
The first one. Is
This one?
yeah.
The diagram below has 2 loads.
That's easy. Only 3 pages, bro.
Can we?
Why don't you shit right now?
I think we might get 3 on Friday.
You get 3.
pages, bro. 3 pages, double sided. Double sided?
The lights.
Yeah, double sided. You see the glare. That's good.
Just 1 or 2.
Not 2.
Do you think the double law is important or the test 2 is important?
Still have a double over there.
The one inverse.
I think it's gonna get some double load.
Oh, he didn't put live. Oh, it isn't online. Oh well. I hope it's raining. I hope it's recording this room. Okie dokes. I made this question up.
What is it, D-cell? Is that 0.105?
It's really low.
No. Okay. So we have a 2 load. We're given ZM. We know the intrinsic impedance. We know the length of XM and the length of XL from the beginning. We'll do open. So we know the length of the open stub is 0.48 wavelengths, and then the actual distance is going to be 0.1054 wavelengths. And then we're asking to find the load ZL. Very simple. So we know that L open is equal to wavelength over 2 pi arctan of
Z0.
okay. So we know everything except CS. That. Okay. Oh. We got it. Yeah, everything's known. Gotta find ZS. Let's rearrange. Times the do that. Should be, I think. That. What's this over here? Right. Okay.
Yeah.
Yeah. We're getting somewhere.
JZS is equal to
And then let's divide, so you times,
CO divided by all that.
divide. You times it, you divide it. ZS is equal to J. Yeah. Okay.
If you plug in the calculator from the beginning, it gives you
Close something like that.
Does it?
You could just see something, right?
You could.
it gives me solve faults.
Okay. So we're having the same problem as exam 2 again.
Yes.
So what was one key point that we had to remember
Add less levels.
of over here? Of all of these, what are we going to assume that they're going to be?
First of all, use L short.
I use L open.
Put lambda at 0.4, and it's just nothing. It's just 1.
It should give you a false then. What was one thing we need to keep in mind with all of these distances? There you go. So what if this length was actually a negative length?
You add lambda and L short too.
So, because on the exam, he's never going to give you a negative length. So let's assume, to begin with, that this was a negative.
I'm seeing for picture, okay?
What if we tried this length? Will it work? It does work. I think it should work with the other one. Okay, it works. Okay, it should work. But I think if you do the solve, you're gonna have to give it this length for it to work. The negative length. Because when you put this negative, the tangent one, the arctan, the inverse, will not like this length.
So you added
Yeah, they're similar.
subtracting 7, right?
They're similar. There's a negative. Because, let's say, no, or is that? No, it's there. 48. 2. Okay, doesn't work. But if we do the negative, it works. So I think this is where some of y'all got stuck on the last exam, where you tried doing the solve, but it kept on giving you a false. So try, always just give it a shot and subtract the 0.5 from it and see what happens. Why would you? Because when you don't subtract it, it's not correct. Mm-hmm. Okay. Well, now we know what ZS is. What happened? From ZS. Oh, I probably should have said it's matched. It's being matched by this. No. Okay. So from yesterday's, the last 10 minutes, last 30 minutes, what does this mean? What are we gonna have? What value do we know already? At this distance, what do we have? Since it's matched.
Match, gamma equals 0. Right.
Mm.
So the lambda cancels with ZS. Okay. So actually, it's 63. Okay. Question.
Yeah.
We confused about something. It didn't give the same answer as me for ZS. I got the same as you, but why? Where's the lambda? The lambda cancels, right?
Mm-hmm.
Actually, previous page.
Does this work?
Okay, we're good.
Yeah, you get roughly the same answer.
Same answer.
Yeah.
Oh, that EXP is just J.
Hmm?
That EXP is just J.
XP?
That exponential is just J.
What happened?
That's just J.
What do you mean, J?
It's box 63J.
What do you
That's
mean?
pi over 2, so that's just J.
He's going to e to the j pi over 2.
It's just J. But it's just all imaginary. Okay, put that in.
Yes,
regular.
it's all
Put
imaginary.
that- Put that in rectangle. That's
Yes,
just
it's
J.
all imaginary. Like, what? Where are you getting? What are you getting to? Okay. We know that. Let's try to do it the hard way. Let's not do admittance. Let's not do admittances and do it all in impedances. So we know that this
Zero.
that's,
So Zn is equal to
let's say, that location, this location, that location, it's that. What is that? Z A.
ZA is that ZN?
Yeah.
No, ZA right here. Because remember, you have to take into account the right side.
So Zn of all that.
All of that, including ZS that we just found, I'm saying it's ZA. The equivalent of ZS and all of the impedances at this location, it's ZA.
ZA.
Yes, ZA.
So
So we know ZA has to equal 50 to make this statement true, because we know Z naught is 50. And we know that is, it's ZS in parallel with Zn. And this is why Twacha wants you to do an admittance, because if they're in parallel, you just add them. But because we're doing impedances,
we have to multiply and do
yes, we got that.
Z.
We know what ZS is.
Just gotta find Zn.
Zn, yeah.
So yeah, it's being on ZL.
So, We're gonna be lazy. Not that
Can I
button.
put ZA and ZN? No.
What happened?
ZA and ZN. Log ZA and ZN.
What do you mean? I'm gonna just do solve. I'm gonna just do solve. Nope, not that one. Nope, not that.
Your salt blends in.
Yeah. So we know it's 50.
I mean,
Look, we're also gonna save the value. 5, 3, 4. Right. Yes. So store it as ZS. It's gonna make our life easier.
Why can't we just turn into admittance and subtract? You just want to go right?
You could do that too.
It's like 1 over 50 minus 1 over
But you already went
ZS.
over admittance yesterday, so we'll try a different method today.
But that's
Because if we do admittance, it's
1 over 50 minus
YS
YS. Just subtract
in
YS
parallel
from-
with YN,
just
which
addition.
is YS plus YN.
so 1 over ZS plus 1 over Z.
Mm-hmm.
So if you do 1 over ZA minus 1 over YN.
Mm-hmm.
And the question that he's gonna, I got confused in the ZS better with ZN.
What happened?
I got confused in ZS better to ZN.
Better?
Better.
Parallel.
Yeah.
ZS right here?
How is it?
How-
He's gonna say in the question.
No, you know it is.
Okay.
Let's get another color. No, my pen is running out. No, I want it colored. Using my. Does it not? Oh, that's so sad. It does just look black. Right? It kind of looks green.
It's greenish. I'm colorblind.
Okay. So that all of this, we will define it as Zn when we put it over here. And over here, we can define it as ZS right there. So when we look at this, we have ZS on one side and ZN on another side.
So it's
Mm-hmm.
okay.
We're taking step by step.
Whole thing's ZA.
Let's not eat the whole cookie. So we'll just start, because like we still have to go through this. This is still, we gotta go through here, then we gotta go through the other one, because at this point there's another parallel.
So ZA.
Yes, because it's ZM and also X and L. So there's a couple parallels in here. You got. Let's just take one parallel at a time. Okay. And then y'all said we do get the same value for Zn.
Yeah, go for it.
Jug it. Would you have it in rectangular or polar?
Both.
Good.
Yep.
If I got it in there, I can miss. So that you avoid it.
You don't have to. You can continue with the minutes and admits get that. Okay. So now we got this puzzle piece. So now we gotta break this up into this big piece right here, where this is
The FXN.
Z in ML. Or ZB. We'll do ZB. Okay. So now we got this. And then we got break it apart.
Well, we know the distance, right? So it's the tangent get out of the equation.
Yes. And we're finding ZB.
Yeah.
Yes.
So this is sweet.
12:30 on the first Wednesday of the month.
What happened?
You don't realize what happens the first Wednesday of every month at 12:30?
Yeah, the siren's going off.
Yes. That's what I was saying. I totally forgot.
And the grade's still not on.
Where is that? Is it the break in? Okay. Okay. Is that what it is? Is that how it sounds here? At home, it just sounds like tornado sirens.
There's like a voice command thing up
Really?
that's saying it's just a test most of the time. First time, one time it happened, like it said there's a tornado warning, and there wasn't.
Yes. Then the length is going to be this length, so this length.
Which one?
ESA.
Why you take the distance?
It's the length. Just like that.
Right here.
I don't know.
This right here. Because we're right here. We want to go to this place right here. Here to there. So we're just moving one step further. We should save this as.
We're solving for ZFL, which is CBZ.
Yes.
Why do we use these things?
Because this ZN and this and the ZS were located right here. So right here. And so we're trying to go back. And so we know that this ZN was the product of all of this going further in. So this is the ZN of over here. So now we just gotta find the parallel impedance of these two at this location, which is what we're finding from ZB, or this ZL that we're gonna be, which is unknown. I'm gonna save it as ZN. Okay. Zn is equal to 50 times unknown x cos theta L, so it's 2 times pi times 0.1054. Okay. So pi times 0.1. See if anyone beats me to it. Did you beat me to it? How about put everything in there? Oh, where did I get this question from? Let's see, did I get it right?
Found all this in, right? So we found all this in. So this is in. Is equal to this, all this being shifted. That's what this is the equation for. Okay. So we're at CL, it's just all this shit. L is just the distance here. That's the distance. That's the distance. Right? So now we're looking at what's all over in CL, which is actually all this shit.
Yeah, it goes.
And then we're gonna solve this.
So you
part also.
here,
Yeah. So the next one is, we found this shit, right? We're gonna take the split up this parallel combination. Because we know ZN
it's better than this.
is parallel to all this. This all of it comes together. Then we do ZL again. the ZL major conforming ZLs. I'm really never seen that something like that. That was what's surprising. This question on the bottom seems to be like 40, 50 next year.
Okay, let's hope this is right. What'd you get?
4.439.
To what?
Negative 0.25.
It's something similar.
Well, I used
The tan one?
62.9 as yes, so the answer is slightly different because you use like 63. 63.5 or something.
Where? For
For
this?
ZS. At the very beginning, when you found ZS.
Oh,
Yeah, so my ZS was slightly like off and all that.
yeah.
So they're going to be similar, but not exact. But the
Let's
last one we
move.
got with it was the same answer. Yeah, 4, 4, exponential.
2. There's a 2 in there.
Yeah, that's essentially what I have. Yeah.
That's ZL, though.
No, that's ZB.
I hope it turns out right. Yeah, we hope so. Mm.
So ZN L. ZN only L is
It doesn't mean ZL.
I got the same answer both ways. answers right. I just did it.
I feel like I'm gonna be off.
No, you're in. Well, I got the same answers you did. So.
No, for the real answer.
Oh, for the final thing?
Yeah.
I guess you just picked a CL.
No, it's a past question where it was just a double stub, two stub, and a two load, and I just added a stub to it.
Why you didn't do the last semester?
What?
The last semester was it's the same.
No, that one doesn't have stub. It's a one load one.
I mean,
It doesn't have two loads. Back to this one. Can I have both? No, but that's not there. You can see both. Nope, not that one. This one. What's that one? I'm gonna title this one ZNL. ZNL. No. Oh my god, I have to type all of this
after
in.
that, from the formula of ZNL, you got ZL, right?
Yep.
Yeah, after that
Okay,
you
so
do,
you
you just.
expanded from the D stop to the ZL.
Mm-hmm. So it's like what he gave,
Yeah.
but
And
just
the
more.
ZB is on the D stop.
Just so
The
more.
ZB is all in the beginning, right?
What happened?
Where's ZB?
ZB, this.
Yeah, is it in the?
So it's this.
What is it? And this. So, you mean
So
here?
it's
Supposed to be around 3.
so it's this.
So ZB.
So it's ZN. So it's all of this. When you take this one, move it over here, and you take the parallel of it,
Then you take all those.
and then that's
Yeah, you
ZB.
take all the yes, you're right.
Shift that over and you get ZB.
Yes.
You're right.
So his original answer is like 25 and 55.
Did you already get something?
Yeah.
What'd you get?
25 and something, 5 on something J.
Is it like 25 minus 50?
Plus. See that type in wrong.
Okay.
So we get ZNL 20.75. The J1 77. L is 5.937.
For ZNL, you're gonna find ZL from ZNL.
937.
You're gonna find ZL from ZNL, the equation.
ZB
Because ZN is here. Here you got here ZN. ZNL, right?
Yes.
No, it's but which links we take the okay, to find this one you take the ZL links, right?
$563. Okay, so this is right. Everything before is right. ZF is in parallel with something that ends up equaling 50. Right? That's that. Is in parallel with the value. So that was right. This is in parallel. We go back. We use 1.054. And that is the parallel version of these two.
So ZA.
Oh, dum dum. It's not that.
Oh, the length is wrong? Oh, is that the whole length?
Yeah.
Okay, that's why. So that's the whole length.
Okay, let's try one more time.
207. Yeah.
Because you in position X. XL and the load impedance.
Yeah, I think I got what you got.
So you have to get all of it.
Oh.
Oh yeah. I remember you switched the length.
Nope.
Oh, I got 21 and negative 47.
Anyways.
Was XM right also? This is for XM?
Yeah, that one should be right because it's only
What's the XM counting?
this length was 1.207.
Okay.
This length was the stub length of 0.1054.
So what is XM back 4.7?
No, because you only take the distance from here to here if we rename this to be the next 0 point.
This between there will be XM
So-
minus the. Use that to find. That is
Negatives don't matter.
5.9%. Minus 4.7. Yeah, so you get that 1.247.
Unless my math was wrong at the very beginning when I made the question. What time is it? An hour. Oh my god. I think we'll leave it here. But that should be the answer. Where we have ZM being 2 minus 32J. ZL was the 25 minus 50J. XM was 4.73 and then XL was 5.937. So it should work. I don't see why it's not working.
For ZNF, which links you got? For ZNF, which links you put?
ZNL?
Yeah.
Oh, when I go back? Point 0.1054. Because I'm here and I'm going back. Because I'm here and I gotta go back. So it's this distance either way.
So you got the piece. So
I saw that distance there, so it'd be XM minus.
No. Because it's from here to there. This distance is the distance away from the load. And I'm defining my load at this position here. Like if it's just the one load, this is the thing I got. I don't know why it didn't work.
It's a close answer.
Not really close.
You mean 21 and negative 47?
Yours was closer. Mine was not close enough. I got 0.8 and then plus 12. Yeah,
Right.
that's a good question. You sure did.
Calculate on the screen. Diagnose.
No, he got 0.1.
It's kind of
0.105.
Oh my.
At least the focus is one. Control up. Yeah, I think you gotta tap it rather than hold it.
Stop focusing.
Tap it.
Where is it at?
What?
Oh my god, let's do it now.
See the worst thing. Scroll to the side.
Well, what did I save as? This is what I put in as the NL.
No, that's not what we had in now. We had the 28.
We have that 28.
What was it?
No, written as 28. Like something.
It was. Where am I getting that value? Where did I leave 28? 28.
E to the 1.079.
No.
People, the list of links at the Z. Yeah.
Was the link this stuff. That's the one.
28. Where's my 28?
You gave us 28.7.
Yeah. Okay. I found that.
That was just like in the exam.
No.
I don't know if you want to say at least 4.
That's my CNL.
That's your CNL was.
Yeah. No.
You gotta replace that in the seesaw equation you have.
I did. Get it. Now. We'll just move on. Tried making a question that did not work. That's so sad. We'll just move on.
Well, I heard yesterday we're going to be here today.
Hopefully, see what happens at midnight today.
Okay. Let's move on. We'll just move on because.
I saw the stuff links.
Where it has to go, you did something a while ago. You don't see me now. Past that.
What's exam 2? You exam 2? That's test 1. What did I do with exam 2? Lost exam 2. Oh my god. There it is. Found it.
You have to get you have to subtract it. I thought we had to put elsewhere.
Do I have the same one? 7 for 21,000.
Let's see, that big wire for loop internal resistance.
That's
what we're on.
exactly.
Yeah. No, we don't have an internal resistance. It looks
For it?
perfect. God. This is memories.
No, velocity. Oh, yeah. Oh, my.
Did you already forget?
Part B, yeah,
Don't y'all have
zero.
this
Yeah.
with y'all?
Get the answers now. Z hat 20 cosine theta T. Seltzers. Oh, yeah, square. R equals 7 ohm. Set it at 40G. Hell yeah. I'm dying with him, but yeah.
This is chapter 6. Because we wanted to do a fun event at study hall.
What is study
Oh,
hall?
we're studying right now.
This is study hall.
This is study hall?
Oh, I remember seeing the announcement about it.
Yeah.
I was like,
Not my event. That's Ryan and Francis. This is their event. So
that's why Francis came and took some pictures. That's
no, that's because that's him being secretary of HKN. So this is technically an HKN event. So yeah.
get it. Double envelope of BDS. So XY plane DS is DC.
1 meter square. So that's square.
Going from 2 to 2, 2 to 2 on that double envelope.
Yeah. Yeah. Yeah.
Z hat EMC1. Yes.
XY. So
Z hat EMC1.
something DX DY.
You forgot the minus M.
There's only one loop over here. N is 1. There's only just one loop.
Oh, what are you?
But maybe we said 2 loops. It's not that hard. All you have to do is double it.
Yeah, that's like which
What was that? X hat, right? No, Z hat.
hat.
Why did I put X? Okay. This
2 to negative 2 to 2.
resistance that I placed on the
Negative 1 to
Enter.
1. Yeah. Negative 1 to 1. Negative
2 to 2, so it's negative 1 to 1, negative 1 to 1,
Beta dot ES. Yeah, sorry, Z hat, so yeah. It's just the same thing. 20 cosine. And values in T X U Y.
Right?
They don't get the Z hat.
Huh?
They don't get the Z hat.
Why?
Oh,
Correction.
Why do you need the Z hat?
Just the direction.
Do we need the Z hat?
he means
Oh yeah. No direction. Dotting. Where you used to do this.
yeah, you look good.
Damn, bro.
I hope it's only T to the power.
Cosine.
How you
I'm not using Y. I'm not using T.
This here it's C1 epsilon. So epsilon. This is epsilon. This is epsilon.
Yeah. Drop the R.
Yeah, it's like ER.
Open. If it's circle, DRBC, that's what it's the name.
What would be the other one?
And theta to pi and the R, how do you get the R? Like the boundaries.
I mean, theta is just R is just the radius. So it tells you the area is something like 3 pi. Area squared is pi R squared. It's just 1 R out. Or it tells you circle with radius pi. So area is 2 pi R squared. Software like by 2. So for A divided by 2 pi squared. This.
And the boundary is gonna be.
Yeah, from 0 to R.
Yeah, either. So that's the best.
Oh yeah, he's gonna do a circle. He's gonna do a triangle. Oh my goodness.
Remember? And then remember, if it's a circle and you do dr d theta, make sure you change any x, y, z in terms of theta. Yeah, and that's all in the table. That one table in the book.
The X equal to
When you go from x, y to the, when you go from the rectangular to cylindrical to circular, I think. Or if not, you just want to, but this was for the other one, the other type of question. But that was it. That was A.
RB.
Hope everyone got that. part B, if the magnetic flux density in the region is given by B, C theta, and the loop is moving at a velocity, determine the current in the loop.
Well, I think it's 0. Yeah, because there's the loops moving and the amount of flux isn't changing.
Okay, so this is the region. So this is the flux in the region. The loop is moving at this,
Wait.
but that's the flux of the.
Wait,
No,
flux
never
is-
mind. It's a new region.
Just 0.
It's
is
a
it
new
2
region.
units or time? I think it's time, so the flux is.
Okay, let's go find the equation we needed for this.
That's Tesla. Use the Tesla. Flux measuring Tesla.
Let me see if I can find that equation again.
Oh, so since the flux isn't changing.
It's not changing with respect to time, so it's just 0.
Yeah, it's 0.
The derivative
The loop
is.
is moving. So it has to change.
No. Think of the loop moving. No, the amount of flux isn't changing. The loop
God,
is
what
moving
was
at
that
a constant
equation?
velocity. Like say a cup, like it's not gonna like they're basically the surface of this cup moving like that at a constant velocity. Not the amount of the amount of flux isn't changing.
There's no T.
Yeah, the amount of flux isn't changing with time, so it's 0.
Since
No, but the flux isn't changing. The flux isn't changing with respect to time.
I'm trying to find.
It's moving at a constant velocity. And the flux is constant.
So it's the whole point.
Yeah.
It's when you take the cross of B and B. Why am I zoomed in?
No. There's no change in flux.
Yeah, there will be no change.
We did this. This is from the exam.
Yeah, there's no change.
Yeah, there's no change in the flux, so there's no current.
Everything's 0.
Yeah.
Right now, the answer's 0.
It's 0, but
But you have to tell him.
I gotta figure it out.
Reasoning, that was just.
You have to tell him the reason. So
Flux
it's
isn't changing.
Not changing, yeah.
So you use this equation. You got yes.
And
Yeah. Yeah, the change in, basically the current is created by a change in flux. In magnetic flux. So if there's no change in magnetic flux, then there's no current. Like if I have a stationary magnet, a coil of magnets that are stationary, there's no current. When there's they're moving relative to each other, then they're current.
Right with the surface visible, there should be some changes.
But it's
We're assuming steady state.
yeah, the loop is moving. The loop is not. The loop starts moving.
Transient, but it's
Maybe. And still, yeah. But it's still steady. We assume it's steady state.
Yeah, if you assume steady state. I didn't say questions.
But the loop is moving. Like the loop is already moving. It's not the loop starts moving. I still think that the flux wouldn't change. Like anyway.
The thing with this one is due to it not being in time.
Yeah.
So when you take the derivative with time, you would get 0. Because you just end up with a constant when you take the cross of B and B, you get a constant. And if you were to take the derivative of it with respect to time, there's nothing to take the derivative, so you just end up with 0.
Chapter 7, huh?
No, it's still chapter 6. Remember, exam 2 is no chapter 7. See if I remember. Let me see, is that the answer? Oh, dang it, I got out of it. Yep. Oh my god, Tacha. Don't tell me I have the wrong one. No, same question. Tacha, how'd you get that? Guess we're close. Okay. Yeah. Watch them.
Yeah.
It's a 1. They're close.
I got 41.91.
Yeah. I don't know. Where were you?
It's too powerful.
Did someone get that?
I mean, you can get it.
You got
You get it.
torches?
It's just too powerful, man. Then you have Omega.
I did Omega times epsilon r divided by c.
Yeah.
Could you say that one more time?
Yeah.
Omega times the square root of epsilon r.
Oh, he did C. He did time. He
Omega
did.
over
He did
R.
this.
Oh,
He
Omega
used
over
C.
So 2 pi times
Radical
10
4.
to the
Yeah.
But it's the same thing.
times
Yeah, you'll
10
get
to
the same.
9.
They're close enough.
So he considered
UP is
both, right?
1.5.
He considered both correct, right?
I don't know.
I mean, they're close enough.
I mean, it's 42.
I usually the blade values.
I mean, I wouldn't.
Both of them 42. Because if you take out,
We'll say they're both 42.
bro, if you take out the mu naught, I mean, and epsilon naught, that's C.
Mm-hmm.
That's gonna be like 3 to 4.
Am I not in chapter
What do
7?
you see? What do you see?
See? Because you take out the mu naught. And it's on side, this is not the way.
What do you see? I'm using UP. That was so much easier. I had software fucking. Okay. I think that's wrong. Within like 6 steps together.
So what, beta?
Yeah. Alright, so what I did was Omega was 2 pi, blah 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 blah. So I got UP. UP was just half. But I got it right.
Okay, that's so much.
But no, because look, if you bought UP, so UP is just that's so hard, but it's what yeah, which is 1.5. 1.5, right? Yeah. I got that. Lambda got 1.5. You got but mine was 10, right? Yours no.
That's the program.
Oh, that's projector.
There's 2 there.
You do the opposite, they basically do the opposite thing.
That's Omega. Divided by 2 pi.
So what's with that?
That's F. Yeah, VP. So VP divided by F. That's lambda.
The 41.9, right?
Pi. I forgot. Yeah, I got all this right. The only thing I missed was 6 points here because I missed. Well, I missed 6 points here. What was this equation? Instead of using epsilon, I wrote mu. The answer to that. Oh, that's an easy 6 points, bro. Well, that's all I've been making. I've been making some mistakes. I'm making sure it's perfect. Yeah, he didn't say it was a plain way. He said he used 8 and 8 to 7.
Using the controversial equation. Somehow y'all don't like this
The
one.
minus, and then you flip it, and
I don't know why it's so. I don't know why y'all don't like it.
so we were taught it's minus. It goes plus minus.
I know, but like, this, just copy from the book.
We're not trying to confuse ourselves on the test. The way we're taught.
Okay. That took forever.
There's only a y and x.
We got a y term, so we can only look at this one over here. But then there's an x, so it's only this one.
Yep.
Take the derivative. We end up with 3 j x.
What's our next?
Right?
Should that be next? Should it be beta?
That's this is a beta.
Yeah. There you go.
I had the right idea, just the wrong letter. Yeah.
Just now 1 divided by.
Like I told you, teacher, you
J's
do the
cancel
math.
out.
He did do the math.
J's cancel out.
He did the math.
Just got a negative.
Look, I think he just did the math.
Yeah, you just plug it in.
He just did the
get
math.
answer.
Hold up. Okay, so we know the J's cancel, so I cannot write. I can leave that one out.
That's
2 times pi.
Yeah, it's not magnetic.
Pi. That.
Yeah.
565. Is that what he got? Yes.
Done.
Perfect, because we're already done with this one. Who? He don't come to school. He's not coming today.
Oh, what? You got a different answer?
Yeah, different version. Different version. Yeah.
Yes.
I'm going to give you the polarization.
I wouldn't recommend it.
X.
Unless it's specified, it's a plane wave,
What's
don't.
that?
Just be safe.
X, X, Y. H is Y.
It's what gonna give me Z. No, it's gonna give me. Yeah, Z positive. Can we do that? I can move it.
First thing it was X.
Mm.
Y.
So if it's giving me forward,
Oh, yeah.
if it's positive, then it's negative.
positive, that means it's negative direction. So x, negative x. You get
Negative, negative.
Yeah, right. It's equal to E epsilon.
Where's D?
There's
Where's
a
D?
relationship almost, you hand it out.
Epsilon.
It's equal to epsilon times electric field.
Yes. Now let me find out. I know it's that. Where are you? I don't even think it's in chapter.
In chapter 7 somewhere.
No. I don't think it's in chapter 7.
No, it's chapter 7 or 6.
I think it's in 6.
Yeah,
It's in 6.
Yeah, we didn't do 7 on this test. It was 6. Or the end of 6.
Wait, hold up. No, yeah, I'm in 6. Where is it? 6. I know that equation exists. Where is it? Where's D?
Let's go chapter. Six, 7.
Okay.
5, 6. No, 4, 8. It's in section 4. It's in chapter 4.
It's in chapter 4?
Yeah. Yeah. The relationship between D and E. Hold up. No, it doesn't. It's not chapter 4. Bro, I know that equation exists.
I think they used it to explain how they get 1 over j omega and things like that.
These equations for H and E.
It is in chapter 4. As per infinite charge. Whatever. Because it has to be signed. Is it E? Epsilon E?
Yeah.
Epsilon E, right? 2 E's, the 2 E's together? And then times omega. Oh. Wait. don't think it's that one. That's right. I don't think that's right.
It's ER times
Would use the ER also.
So D.
No.
CD is equal to the permittivity times electric field.
Where'd you get that?
I just wrote it from what I told us in class.
I also wrote that.
Relationship between induction current,
I also
D,
have it. Where's it?
B,
Where's the chapter? It has to be chapter 7 somewhere. Chapter 6.
Here it is, 6.44. Application page 299 on the book. Example 6.7.
Okay. I'm in 299.
Here's that, I just read it. For the middle of the page, where it says equation 6.44 with D equal to epsilon E leads to ID equals blah, blah, blah.
So you're done with it.
Okay.
6.44.
That's that. So that times the 4 times epsilon naught. Okay. And then we take the derivative of that. Respect to time. Nope. The math ain't mathin'. Because we take this, we take, okay, let's do step by step. We take the time of it. Okay, so this did not, I think, what did you mess up? think Torture messed up on his solution.
Really? Why it's negative? You take the derivative.
That's not the problem here. And then you times it by the epsilon.
Yeah, epsilon is E0 times ER.
You just multiply it by just the epsilon. Now you see, you do need the. You need the 4. You do need the 4. You do need the 4. You need the 4. Because that somewhat gets it to the answer. What would you do? What is this? What?
Took the respective time, right?
Yeah. Like, that's right, right?
Yeah, okay, you have no negative. Like cosine, derivative of cosine is negative sine. Yes.
Like, is the math mathing?
Minus
Is it mathing for
Z.
y'all? It's not mathing for me. I get it too.
3 beta sine. Scroll up. Rest of the page that's hidden.
Hmm?
I mean, the actual paper we were on.
Unless you convert
So
this.
Z is equal to. Let me write that down.
Unless what he did is he turned this into a beta.
Let me write this down.
Oh my gosh, what did you do that? I think he did that.
I think you multiply epsilon r with epsilon
So
r with
3 over omega E. So J's cancel out times Z hat 3. I mean, 3 is already there. So beta exponential blah blah blah. You multiply that by omega. Not omega. Yeah. Let's not do that. Let's just do cosine of omega t plus whatever.
Would you multiply the primitives?
When you do that, you get. Well, so you're multiplying this by epsilon and then by epsilon. So the epsilons cancel out. When you take the derivative, you get negative sine omega. And omega stays. So the omegas cancel out, so you just get 3 Z hat omega t. Yeah, you get the same thing. I got what he got. That's what he got, right? Negative 3 Z sine omega t.
How'd you get that?
Well,
after this right here.
So we got E as equal to, let's do this. So it's whatever H was when we did all the cross products. So that's equal to Z hat 3 cosine of omega t plus beta x, right? So we have to divide that by omega and epsilon.
Oh my god, buddy.
Right? To get that t equal h.
Yeah. Mm-hmm. We got
And
8.
then to get d, we have to multiply by epsilon. Right? E, we multiply e by epsilon, so the epsilons now cancel out. You take the derivative, you pull out an omega, so you get z hat 3. Now you get negative sine omega t plus whatever.
So he was using H.
No. Just remember h. So then the omegas cancel out, so no. Right?
Oh,
Because h is,
I see what he
h
did.
is just whatever we got
Yeah.
after we did the cross product divided by J, omega, and E. The J got canceled out. You take derivatives, omega gets canceled out, and you multiply them by E, so the E gets canceled out. So you're just left with the derivative. I mean, after you take derivatives, the omega get canceled out. So you just get negative 3z.
125.
Yeah. So if you do omega times.
Okay, so we do get the same answer.
So
Okay,
if you do
whatever.
omega times that 565,
I don't know
you
what
should
you
get
did,
that.
Twacha.
Right answer.
Twacha, just use the stuff before. Like, Twacha, you're making your life harder. Okay, guys. So we take. I see what he did. Yeah, I see what he did. I see. Yeah. He used this. He used the putting
Unsimplified.
stuff in it.
Yeah, just use an unsimplified version.
Whatever. Whatever. Whatever.
The unsimplified version of E was.
You should end up with 125.
Beta was that, so profile beta times 3. Then you want to do that. Forgot to mean
Yeah, you gotta see, you took away 3 points for that shit.
No, bro, 10 points.
Yeah.
What the hell are you talking about? The whole question is wrong.
Forgot one here too.
It's not that, like.
Bro, whatever.
E times E, take the derivative.
Whatever. Whatever, Twacha.
it's there.
Okay.
Now just review the steps.
Twacha just whatever. Twacha just whatever. Can't
How
wait.
did you got this 3?
Huh?
How did you got this 3?
I keep one after every exam.
Oh,
Let's go.
Let's see, do I have the same one that Twacha sent me? Let's see. I do. I do have the same one.
The epsilon 2 sigma.
It'll be on Canvas after. You'll have the solutions. Okay, whatever. Okay.
Carbon, the attenuation constant in beta has seen that.
Oh, it's those ugly equations.
It's that, what was it, like 1 plus something, square root of 1 plus
I saw it,
something
yeah.
minus 1. all to-
Or
Or you can do
I
assumption
think,
1,
or if you can find to see if it was a
a good conductor or back.
if it was a good conductor.
so the question is, you have to use the general formula.
Yeah, he asked us to use the general formula. If you make the wrong assumption, you're fucked.
Fine, then Twacha, we'll do the other one.
Omega times.
So sad. Sad.
Now you have to find, what's the first step? Find epsilon prime and epsilon double prime.
Okay, please, y'all need to like, if you, I hope, oh my god, that these equations need to be programmed because
They're going, right?
they are
Let's see, I think epsilon prime.
yeah, epsilon prime is equal to epsilon.
And then
Epsilon double prime is equal to
sigma over
omega.
omega. Then we know frequency.
Okay, guys. I'm not doing the math. Y'all can check it.
Over 2 parentheses.
Let's see. Does it? Let's see. Do y'all know it?
1 plus epsilon double prime over epsilon squared, all that squared.
And this one is equal to sigma
Oh,
over
plus-
omega e.
Yeah, then minus 1. Close brackets a half hour. Yeah, it's a half hour. Yeah. The fun.
And you should get something around.
Use this one. It's losses.
There you go.
And then beta is the same thing, just plus 1.
Yeah, I'm not writing that.
No.
What's next? Skin depth.
Skin depth. One more
What you got? Just a Oh, I got 143.
Where is this equation?
End of chapter 7, it's like a table. Like has it.
No, I didn't have it.
How many variables do you use?
Oh, it's at the very end.
Yeah. It's like one of the conclusion
Our
tables.
version was the ER equal to 4. That's why. ER difference for the version. And sigma was 2, right?
Yeah.
Meters. So. Then UP, it's like 2 pi over beta. There's another equation.
No, it's another one. I think that one could work though.
That's the one I use. Just 'cause I couldn't remember what the other one was. I have it on.
Wait, was omega given?
Omega, we were given F, so you can find omega.
Oh. That's a 5. There's a... I hate those.
Bro, no, it's 5. It's 5. I got 268 instead of 274. Oh, hold on. Never mind.
11. That was hilarious.
Propagating in the medium plus x direction, polarized along z. So it's
Yeah, here's the magnitude. All you have to do is grab the base.
polarized, so this is z.
Z.
Yes, I got that part.
A plus that, right? It's a minus alpha times x. That's the propagation direction.
X. Good job.
Then cosine of.
How much
of omega t.
And then it's
Then you just have to find A in the base and K or beta. Actually, no, we already have beta. R1.
okay.
Oh.
And then he wanted it in time.
Yeah, you have to use cosines.
Do we know what time is?
Your cosine, right?
Yes. Some of y'all's homework. Oh my god, chapter 7 was a disaster. I really hope y'all looked at your homework 5 because
So you had
some of those answers were
e to the alpha x cosine omega t is beta x. And base was 0.
Thank God.
yay, we done. No, I'm kidding.
Part 3 it's a plane wave. Explicitly stated.
Rose. I'm already tired.
I gotta use A to C. Right there. A to C. Remember all this.
Are you just kind of looking at my tablet?
I can see the corner of it. I'm like, oh yeah, that's the table. I wrote the whole thing. This is different. Maybe that works out.
Yeah, but the mu is 4 pi.
Yeah.
Yeah, I got this one. Yeah. This one.
0. Okay.
Yes.
Okay.
What's the pages?
I use that.
B.
H is S, H is 1, 0, 0. And then E is just 0 on the Z, so 0, 0. G. Yeah.
No.
How
much signal you have?
2.5.
Oh,
A Y hat.
Yes. Because it's X and Z, so we get the Y.
that's
That's me. That's me.
And then there's a negative in front. Yes. Right?
We did.
Yeah,
We have
just
sigma equal.
later on, yeah.
And then it's just this.
Sigma equal 2. Because I remember Christian told me.
I'm sigma is 3.
Sigma equal
Right?
2.
Yeah.
For that, for this, is that?
Yeah.
Yeah.
All divided by that complex eta.
And then eta was
A number.
number.
And then a complex number.
Oh, right there it is. Where's the? Oh, it's right there. It's just ER. Only ER was given. So,
So you use ER or you use a complex eta?
huh?
Use complex eta?
Zero.
Eta.
Oh my God, that's the lossy one, lossless one.
Yeah. I think it's on the table. Sigma.
That one table.
Yeah.
The
They
ugly
have
table.
the sigma, the alpha, the beta, and the complex eta. Or you could use that, but you have to use epsilon as epsilon complex. That one.
Well, we need to know.
So much is what to do.
See, essentially to know. No, it's
It's gonna be close to the midnight.
because I did.
Yeah, whenever you said use etas, complex eta.
You end up with
No, you don't have to give you partial credit. No, it's we can AVD. That part's only worth a couple, it's not that much. That one's worth like 15 points. It's possible. Because you already did the cross product, right? That's like half the points. So half is just getting the constant eta and dividing by that. X plus.
okay. That was horrible. Now we know we gotta program all those equations. That's okay then. What's the last thing? Oh my God, we're only halfway done. No, we're
Determine the time average power density.
at 3.
What was that one? That was the 1/2 RE times H conjugate or cross H conjugate.
E cross H gets you an X. Alpha was, there's an X. So it's X on X. Lovely. Right? Oh, that is right. This over here. This. Plug in X. To that. Then you take the square. Then you take the magnitude. Then you take the square. But it's the phasor. So you do this one. So it's 8. Square, that's 16. No, that's 64. I gotcha.
About 2 is 32. About 8.
Anyways, you plug in X, you plug in this, plug in the 3. Oh, sorry. Wait,
It's not AMR, right? Is it 125? No?
¿Qué pasó?
Are you going to use the 125 for the average power?
Where?
For ADA.
Eta.
No, it's complex eta.
Yeah.
That's a C.
That's a C.
Eta complex.
Oh, sorry. That's a C.
Let's see. That's how it's
It looks like a C over here, but it does not look like a C over there. That's a C.
You see?
That's a C. That's a C. He loves the zeros.
No. Not mine. My number is
Another zero.
I think that's right.
Yeah, no. That one was horrible. She really doesn't like y'all. Who gave you that?
Which one?
The one we just did.
Bruh.
Bro, I need something. I'm gonna be back. I'll be back. I'm gonna go grab something. Just reflect on this one. Reflect on it.
This one wasn't that bad.
As you reflect on it.
Goddamn, bro.
How do you like our exam 3?
Bro, for question 1, I got my numbers. I forgot parentheses, right? I got it changed the whole fucking thing. I was supposed to get 170, I got like 270. Because I'm gonna try. Wrong ADAX? What do you mean wrong? For number one?
For BCB or CD.
This number?
Not for number one.
Oh, yeah. Oh, yeah, the NC. Yeah, I put. It should be the NC. The NC. I didn't use it. I guess we're taking the phone. No, we're taking the phone. Which one? That's what I'm looking for. I forgot the square. Give me different numbers. But all my numbers correct.
That's what it happens in the math class.
How the fuck is? Bro, I hate that we're gonna get one day off.
How the fuck is ER distributed 1400?
Where? Where you see ER now?
Just look at the ENC. It's 3.0. UGBT is 3. Oh, never mind, 3.0.
Yeah, 3.43. Also, the phase changes. You see that too?
Yeah.
I got 43 minutes to figure out the equations I need for this question.
It's not that bad.
Yeah, we're taking the phone.
Question one's always a hard one.
Hmm?
Exams.
The second one?
No, I said question one's always a hard one. Right?
Oh.
Exams.
For y'all, yeah.
All of our exams we second question one. Frequency 1/2. Yeah, that's not that bad. Yeah, it made it worse by asking the magnetic field with the exam.
You see, I just want to like, so what happened inside of the frequencies. So we put this. What's the object?
Interesting. Y'all think he's gonna get there on time tomorrow? Get there on time.
Read the exam.
Get there on time.
Watch.
Think he'll get there at 8 in the morning?
I don't know. He's usually always late. So that.
Let me look through the chapter. Yes, and an announcement was also made.
I got a review. I got a review.
Oh,
She said. Christian told me he's gonna fucking skip people. Christian is gonna skip.
I mean, I think he's good enough where you got a B or C.
Then it's intelligence of curving.
If open, if someone calculates his grade and he got like 65 total, is that a passing grade?
Depends on how hard he wants to curve it in. It's honestly up to him. All the averages were, say, between 30 and 40, so. Expecting at least a 20 point.
So what's the example for this? Dang it. Is this polarized? I think it's polarized. Yep, it's polarized.
He didn't ask us till now about the left hand, right hand polarized. He have not asked us. Yeah, so much about those.
Okay. Okay, dokes. Yeah, very similar. Yeah, uh-huh.
For example, what?
Very similar. Golly.
He does that sometimes.
I guess. So you just take the square root. I guess something's possible.
Tangent's equal to the square root of 3.
Okay. So that should buy.
It's 2 pi.
Square root of 3. You got,
Do we have a value for that?
It's like 60.
More than 60 degrees.
Yeah.
That's a radius.
And then you got theta t from it.
This smells long.
1.6.
Huh?
Give me this. I want you to solve it by yourself.
No, he just, instead of him putting 1 and 2, he did 0 and 1.
No way. It is. Okay. Why you did that?
K1, K2
Oh, K2.
relationship. It's just difference between square root and PR.
I got K2 equal to K1 square root of CR, then lambda, then 2 pi over K2.
Did you get 0.5?
I get 0.5. 2 pi over. What's the equation?
What am I missing? What am I finding?
Your pet.
There's one.
Now you got it. Let's see.
That.
Omega.
That.
The frequency omega. So the radiant, the angular frequency.
Bro, he forgot to put it. I got both of them.
I guess you meant angular frequency.
Angulated
Omega.
You wanted the same. Thank you, Watson.
You smell
Oh! Theta T is over here.
Yeah, I got 0.5.
Oh my god.
Get 30.
What we got?
30.
Over, I have the answer.
Get my radiant, so I know what you got.
Wait, what am I doing?
26.
Okay, you did something.
Yes.
But then this.
I got 30 degrees.
That's right for orange.
Yeah, I got this. 25 or something. There's a lot of conversion for the example.
Pause
Multiple versions.
Yeah, multiple versions.
to do it.
There's multiple versions.
No, just multiple versions of the exam.
Yeah, because some people don't.
Yeah. That was good. That was good. This, no. No. What's omega? Oh, it's right here.
Yeah.
I over. I see.
Thank you, Twassa.
Yeah. Yeah, yeah.
There you go.
Part A done.
That's part A.
Part B. Find the find the reflect angle.
Yeah, no, find the reflected vector field. Find the reflected electric field.
Part C is transmitted.
Okay. So since EI is along Y, is perpendicularly polarized. Y is perpendicular to the plane of incidence containing the surface normal Z and propagation direction X. So we're perpendicular, so we're using the perpendiculars.
Okay, grandma, and then.
Okay, so let's start from the beginning. From equations.
Oh my god.
8.59 and 8.60.
Oh my
Wow,
God.
I did it backwards. Oh my god.
If you got example 8.29, that's 3, then X, Y, and Z. And like,
Checking my phone for the Canvas announcement.
Oh, for the grades?
But he ain't gonna put it.
No, well, I think he will put them in. That's just my vibe. I think he
I
will.
don't think so.
I think.
Oh,
he
that's a
will.
2.
Fool.
That's a 2. That's a 2.
Why use that if it's. That's for non-magnetics.
Is it
It's
not
not
real?
magnetic.
Yeah.
It's
Nice. Nice.
I mean, it doesn't say it's
You
you
can
can
still
still use
use
the other one.
This is when you don't know theta t, but it's regular theta t.
Yeah, I do.
I mean,
Yeah.
I got many.
Because that one, all it does is just replace theta t with,
Yeah, it was theta.
with that equation.
No, we did.
am I okay? Am I okay? Check.
Oh, really? You ain't check?
No, make sure this is correct.
Like 0.5, I think. Negative 0.5. It is.
What happened?
It's like negative 0.5. I think. It's trying to character you freaking.
Oh. You can charge it also because it's page 2. Should I get back up in 100?
Sure. Oh my god. Wait, so what do we get? Negative point or point or 6.5? What did you say?
6.5, yeah.
Okay.
1,000 plus that. It's probably gonna get it out when it's very well.
4.45? I think it's 4.45.
No, 435.
Yeah, 4.35.
I'm good at something bad at this moment.
It's that, yeah, because that's good and so well.
All you gotta do now is multiply the amplitude of 7 by that. Seven y hat.
No.
Bruh.
Huh?
Never use those equations.
Which ones?
No. Left is equal to. No, we should want to double check it. Yeah.
Where's the? Wake up.
Right here.
Do Sundays, Tuesdays,
I've been
and then just homework. And I've done most of this. I have a few assignments, but I have something else today that I'm going to do in my attendance. This environment is just not. So I'm just reading some of this, but I'm just catch up on it. What are you doing? Are you done with everything?
You're swapping around assignments right now. One course, different courses, design, tutoring. Yes. Since I got here, since like 11, I'm going to bring one back and forth.
Right? 3.9?
No, this is just studying.
Hold up, let's make sure. Yes, it's 2.9.
These are math congrats.
Oh, but there's a minus. Does he want it in time? Oh, he wants it in time.
Yes, which is the fun part. It's all in time.
Oh yeah, especially I think he knows. He knows.
He knows.
He knows.
Struggle converting from phaser to time.
He knows. Even though he didn't look at your homework 5, he knows.
You know, people struggle converting between phaser and time.
No, it's a minus. So from here we can find our reflected, which are reflected should end up being around Watch, why didn't you just leave it in this?
Because he likes challenging people. Okay. We both know he likes the time domain.
Okay. There's B. I think this whole middle thing was a little bit excessive, but we'll just leave it there. Now we gotta find our transmitted. And we're done. Questions, concerns?
Too many concerns.
Well, this was fun. Said no one.
Question number one, exam, so.
Do you want to do it? Or I can finish in 50 minutes. Bet you I can. I bet you I can.
This single question.
Hmm?
This single question.
Yeah. And from here, that's in parallel. That's equal 50. So Z and Y's. The admittance is something else. Okay. Start from we know that's equal 50 because this equals 0. And it's going to be ZS